Let's now take a look at our panel that we have seen. This is the part of the bus bar that we all saw together. This is our circuit breaker, which is the electrical switch. This is the current transformer, which is the current transformer that we will talk about in a bit. This is the voltage transformer, which is the voltage transformer. And of course, we have from the back, okay, let's see what we have. The first thing we have, right? What we all saw together is a part of the bus bar, which is a piece of the bus bar, or what is called the metal bar, exactly, or sometimes referred to as an electrical bus bar. It is essentially the part through which power flows, meaning it is the connection point or the common point where the incoming supply is provided and the outgoing takes the supply from. So what did he say? He said it distributes high current power, meaning it is used in high current power distribution, distributing this high current among electrical sources and among things that draw from you, neither more nor less. It is not a static part, something that moves or anything at all. Okay, I would like to clarify for you that when the bus bar is installed, of course, it comes with the manufacturer's manual, including the FAT test and others. You have the bus bar, and when it is installed, of course, a cell with another cell, it is naturally assembled with bolts. This is a low voltage bus bar, but I am talking to you about a medium voltage bus bar, which of course has the insulating material, which is the resin, as I told you, right? But what I want to clarify for you here in this part is that when you come to tighten your bolts, you use a tool called a torque wrench. This wrench, engineer, is set to a specific torque, a certain Newton meter, based on the manufacturer's recommendation. The bus bar is tightened, and after it is tightened, you take a highlighter and start making a mark like this. This mark is drawn on the bolt itself. Let me enlarge the area for you, showing the bolt itself and the part of the lamp, so that when these bolts are exposed to the electric current and the magnetic field, a series of vibrations begin to occur due to the expansion and contraction of these solid materials as a result of the magnetic field. Then you start to notice that there is a loss occurring. So you might see, for example, the bolt with the red mark here and the bus bar with the red mark there. You immediately understand that this bolt is a bit loose and needs to be retightened. So this part is also very important. However, this has a story in tests called contact resistance, which is not our focus in this course. Here is the circuit breaker, our electrical breaker. What is the electrical breaker? It is an electrical equipment. This electrical equipment is used for two things. One is control, and the other is protection. Control or automation, which is control, and something related to protection, which is protection. Control is if I want to connect or disconnect any load I have, connect or disconnect any load I have. Very good. So here, engineers, I want to connect or disconnect my load at will, just like having a switch for each socket to connect or disconnect your load by yourself. That's one thing. The other thing is that it acts like the word U, but I know the fuse, your fuse, which blows or breaks the circuit or disconnects the circuit in case of a short circuit. It breaks the circuit, whether it's in the cable, the load, or anywhere else. Just like the panel you have in your apartment, the panel you have in your apartment contains a set of circuit breakers, but they are called miniature circuit breakers or small electrical breakers or miniaturized electrical breakers. Exactly, it's called a miniature circuit breaker, which means mini circuit breaker. The purpose of it is that if you want to leave the apartment and you want to turn off this switch so that electricity doesn't reach the entire apartment because you're afraid of the presence of any faults, while you're outside the apartment, you can turn it off. The other thing is if you're working and, for example, God forbid, your child causes a short circuit in the socket, or your wife is using an electrical appliance in the kitchen and the appliance has a problem and its insulation fails, causing a short circuit, what happens is an electrical current doesn't pass through the wires, causing them to melt. It prevents the electrical current from igniting the blender or the coils you have, which could cause a fire and harm the person using it. This chromalum component immediately disconnects to protect your circuit against the short circuit. At the same time, the source that feeds it, which has the fault, starts to isolate the faulty part from the healthy part, from the rest of the apartment that is completely healthy without any issues. Okay, where am I here now? All right, then we come to the measurement attempts, which are divided into. And of course, this is a course we just finished last week. The idea is quite simple. The word, as I told you at the beginning, what are these attempts? They are essentially, as you know, in our course, as I mentioned earlier, a static device. So here it's a static device. Let's say static device, not static machine. A static device transfers power, meaning it transfers power between two circuits, which are the primary and the secondary, right? Correct me if I'm wrong. The attempts of quality and current here are also static devices or static machines that transfer, but not power, rather they transfer current between the primary circuit and the secondary circuit, and the voltage transformer transfers the voltage between the primary circuit and the secondary circuit. You might say, is there a transformer that works with the current only, stepping it down or up without doing the opposite with the voltage? No, it definitely does the opposite with the voltage, but here its circuit is connected to a load. How does it look here? This is the idea for you. So I'm telling you that the current transformer, let's focus on it because I can't go into too much detail to avoid getting sidetracked. The current transformer, the static machine, transfers the current between two circuits, primary and secondary, and always by transfer LL. And always, what does it do? It essentially steps down the current, meaning it significantly reduces the current from high values to lower values, which can be effectively handled. I can use them with various measuring and protection devices, such as whether they are metering devices like the ammeter, power meter, energy meter, or protection devices like the IEDs, which are specifically protection relays. The idea is quite simple. You have currents in the switchgear or in the voltage that are 1000 amperes, 2000 amperes, 3000 amperes. So you need a device to measure these currents. How will you measure the current in amperes like that? You definitely need a device, a very large, massive device, which is not practical. Imagine if you want to take this measurement to an electricity meter like the one you have at home. The electricity meter at your home is for 30, 60, 90, or 100 amperes, for example, but not for 2000, 3000, or 4000. How would its size be? Right? So what do? I use a current transformer in the middle, which reduces the current from, say, 3000 amperes to 1 ampere. How do I know that the primary current is now 3000 amperes? Well, these devices, engineers, are either digital or analog. In both cases, there is something like a compensation factor. The compensation factor means that in numerical or digital devices, you find a setting inside, similar to the settings on your mobile phone. You tell it, well, the ratio of the current transformer, the conversion ratio of the current transformer is 1. So when it reads 1 ampere, it understands that the current flowing in the wire is 3000. If it reads 0.5, it understands that the current is 1500. If it reads 1.5, it understands that the current is 4500 amperes. All right, that's good. As for the voltage transformer, the exact same principle applies, but with respect to voltage. All right, then we come to the auxiliary relays. What are these? These are important to me as auxiliary relays or contactors or other similar devices. Okay, so what are auxiliary relays or contactors or these things? Right, when I have an auxiliary relay, what does it represent? The auxiliary, which is not a single-use device, is used for more than one purpose. It is used for supervision, monitoring, in control circuits, in control systems, or in protection circuits. Regardless of its uses, when we delve into the schematic diagram and understand it, we will know it is about. The important thing is that the word in Arabic, if someone is working in Arabic, means auxiliary relays, auxiliary relays, auxiliary relays. I wrote it here for you and told you that it is used to assist the indicators or to work with me. So how does this work? Let's see together. Here it is essentially a coil along with a set of auxiliary contacts, which are in essence the auxiliary points, or what they call contacts as they are known. Very nice. So you have this coil with a set of contacts. Basically, in this context, some of them are called normally open, and some are called normally closed. Normally open, and normally what? And normally closed. All right, all right. The term normally open means its default state is open. And normally closed means its default state is closed. So when is it open? I mean, when is its default state open? And when is its default state closed? As long as this coil is not working. What does it mean not working? Let's understand what not working means. Now, if I came to you here as an engineer and I came to tell you what, and I came to tell you that if you put voltage on this coil, whether it is AC or DC, regardless of its type, as soon as you put a voltage difference on this coil, it starts to create a magnetic field that pulls this contact. So it was normal open and became close. I mean, it was normal open and became close. It did not become normal close and became close. It became closed. It didn't become normally closed. It became closed. And the normally closed became what? It became open, meaning it opens for you. So the word normally refers to the natural state of the auxiliary relay. The natural state of the auxiliary relay is called, look here, focus with me, I'll write it down for you so you remember it, while watching the video is not operated, meaning it's not working or no voltage. Applied means there is no good applied to its coil or not, or let's say it's de-energized. What does de-energize mean? It means nothing is energizing it, nothing is activating it. Any of these terms refer to the context. So when I tell you this contact is normally open for the auxiliary relay, you should immediately understand that it's normally open when the auxiliary relay is de-energized, not operated, or there is no voltage applied to its coil. The difference between it and the contactor is the contactor like the auxiliary relay, but it comes with 3 additional contacts. But what is it called? It's called a power contactor. This contactor comes with 3 other contacts, which are usually what are they usually? All right. Are we clear on that? Okay, great. Some people are saying the sound is cutting out. If some of you have clear sound, it means the issue is with your internet. If all of you are experiencing sound issues, then the problem is on my end. Engineer Mohammed, so the youth can confirm the sound is fine. Okay, Engineer Mohammed Al-Maghribi, if you want to exit and re-enter immediately, I will make you an admin right away, just to ensure the sound is good. Okay, excellent, guys. Okay, here you have these 3. They are always used as power contacts. What does that mean? Or, they are referred to as power contacts. So, Engineer Rashad, you have 2 types of contacts. Either these contacts, which we call auxiliary points, or we call these contacts power points. What does it mean when I say power contactor? All of you who work in factories or elsewhere use these contactors to operate motors, transformers, fans, etc. They are used to handle power. What does that mean? It means you use these contactors to send signals, use them in circuits, or to operate lamps. It gives you an alarm, sends a signal to the SCADA system, or sends a signal to the SAS, which is the substation automation system, and so on. So it has power, meaning it carries very small currents in the milliamp range. That's great. However, these power contacts are specifically designed for currents of 1, 2, 5, 10, 15, 20 amperes, or even more, depending on the type of load you have connected to it. The same contactor, this contactor carries both parts, which are the coil and auxiliary contacts. The contactor consists of a coil and auxiliary contacts. And in addition to these, what else? Power contacts. The auxiliary contacts are used for signaling and alarming, meaning for signal circuits and alarm circuits. Additionally, here the power contacts are used in power circuits depending on the application you have. Look, engineer, here you have the auxiliary. As you can see, it is essentially a coil, all right? And here is its contact, which is a normally open contact. Good. So the situation is as follows. I start with this coil, as mentioned, and these are your contacts, which are the contacts. Now here you have something called a movable armature. Do you see this arm coming down and connected to whom? To these contacts. All right, so now you bring a source, whether it's AC or DC, as I told you, depending on whether it's AC or DC. AC stands for alternating current, which means the current changes direction periodically, while DC stands for direct current, where the current flows in one direction only. Very good, okay. Let me just make sure the entire circuit is complete. Ensuring the circuit is complete is crucial for the proper functioning of the system. I hope this explanation helps you understand the importance of having a complete circuit and the differences between AC and DC sources. Okay, so what did he do? He now brought a battery here. This coil draws a very small current. When you connect this DC battery, meaning positive and negative, to the coil or AC, But since our control circuits are all in the switchgear or in GIS, whether it's medium or high, or even if it's low, let's say more medium or high, it actually operates on DC. Of course, sometimes you find circuits that operate on AC. The important thing is that when you apply voltage here, this coil gets energized or starts working or becomes magnetized. It then begins to pull the armature inside here with the magnetic field, which you can see. So when it pulls this armature down, look at it, it will pull it down completely. Look, when it pulls it down, what will this arm do? It will push the contactor. Look. Look, it goes down gradually and pushes here step by step. Here, as soon as these two touch each other, meaning they become closed, the circuit is closed with a lamp in the circuit with an indication alarm, as we will see. Regardless, once they close, you can use this contact in any circuit as you wish. Again, look, the armature will be pulled down. All right, here it is again. This armature will be pulled gradually and will press on this contact here step by step until these two touch each other, closing the circuit. Here I had placed a lamp with a power source to turn on this lamp. So this is the story of our auxiliary relay. As for its application, we will see what it is used for during our drawing. Now let's move on to the miniature circuit breaker, which is mini. Centripetal refers to a miniature circuit breaker. The miniature circuit breaker will be installed, and this is not a fuse. Its purpose is the same as the large circuit breaker. The large circuit breaker is used for switching and connection as control or automation and as protection in case of a short circuit. The same applies here. It's a circuit breaker, but smaller. It is used for switching and connection, but specifically for the control circuits in my cell. And it also provides protection in case of a short circuit.